Okay, we're going to talk about complex eigenvalue phase portraits. Um, Pablo Sanchez does an amazing job on his YouTube video, IB Vodcasting. This Here's the link. There's also a link in Canvas. But anyways, you can take notes from his for the video for the first few pages. But I just want to show you my notes. I and for the whole key here that I'm going to go over now, I'm using color coding. So for the spirals, the stable spirals where A is less than 0, I'm using blue. For the unstable spirals where A is greater than 0, I'm using red. And for when A equals 0 for the central circles and ellipses, I'm using yellow. And as Pablo Sanchez says, when you're dealing with complex phase portraits, we only care about the eigenvalues. We won't need to calculate the eigenvectors. So this is going to be a much easier assignment than the previous one when it was real eigenvalues and eigenvectors for phase portraits. Anyways, Pablo walks you through this stuff. Hit pause if you want to copy it, but I would watch his video. And Pablo goes through this. You can hit pause if you want to. And what I did, this tool, Pablo created this GeoGebra tool, which is amazing. Oh my gosh. All you have to do is if you go to this link and you type in your equation here, y and negative x. So basically, if you know the equations for my derivative dx dt and dy dt, you can type in your equation here, and then you get your phase portrait. It made it much easier to draw my pictures. So for this assignment, I drew the phase portraits for you. Anyways, here is the next one. Hit pause if you need to. He walks you through all of this. And if you go to his link and you type in the equation, you can move the dots and see this dynamically working for you. Okay, pause if you need to. Once again, pause if you need to. And last one. And then, so like I said, he walks you through this. So now I'm going to walk you through the problems that he doesn't walk you through. So let's start off with this one here. Okay, so we've got the system, find the eigenvalues. So if I convert this to a matrix, I've got 2, -5, 1, and -2. Okay, from the coefficients of my my derivative formulas here. So now I want to find the eigenvalues. So we use our relationship here to do that. So I'm going to do 2 minus lambda, and then -5 here, and then 1, and then -2 minus lambda. And we're going to take the determinant of that, so make this equal to 0. So in making this equal to 0, I'm going to have this times this. So I'm going to have 2 minus lambda times -2 minus lambda minus 1 times -5 equals 0. And now we can find our determinant. So we FOIL this out. We get 2 times -2 is just -4. 2 times negative lambda is -2 lambda. Negative lambda times -2 gives me positive 2 lambda, and negative lambda times negative lambda gives me plus lambda squared. And -1 times -5 gives me plus 5 equals 0. Combine my like terms. These cancel out. And then I've got -4 and +5. That's going to give me 1. And so we've got lambda squared plus 1 equals 0. And we know the difference of squares up here. If I've got x plus 1, or I'll call it alpha plus 1 times alpha minus 1, we know that's the difference of squares, which gives us alpha squared minus alpha plus alpha minus 1, right? Difference of squares is alpha squared minus 1. So, but this is lambda squared plus 1. So this simplifies to lambda plus I times lambda minus I. Now let's just say you didn't know that. Okay, you forgot this, you fell asleep, and your brain was tired. That happens. So there's this magical thing called the quadratic formula. And when I see the quadratic formula, it makes me want to sing. X equals -b plus or minus square root b squared minus 4ac all over 2a. Okay, that's the quadratic formula. So in this equation, a is 1, b is 0, there isn't a b, and c is 1. Right? So if I wanted to plug this into the quadratic formula, then so b is 0, so I have x equals 0 plus or minus 0 squared minus 4 times 1 times 1 all over 2 times 1. Right? And hopefully you see this starts to simplify to plus or minus square root of -4 over 2, which ends up being x equals plus or minus 2i over 2. So x equals plus or minus I. Anyways, my eigenvalues are lambda equals I, and the other lambda equals -I. So since we have a plus bi is our uh, our relationship here, and there's no a here, there's no real part, so we know that a equals 0. And since a equals 0, we have a circular focus. Focus. I can't spell. Okay, so we got a circular focus. So, and you can see when I typed in my equations here, this kind of does look like it's going to, actually it's going to look like an ellipse, isn't it? But before we get started, find the derivative, or find the slope, right, of the curve at 1, 0. So if I've got my derivative, and when x is 1, we're going to have 2 times 1, and then y is 0, so minus 0, and then I've got 1 minus 0, and that gives me a direction vector of 2, 1. So if my direction is 2, 1, that means in the x direction I go 2, and in the y direction I go up 1. And so my slope is 1/2, and my direction is this direction. Okay, so let's draw a curve starting at 1. So 1, 0, sorry. So I've got my dot here at 1 comma 0. And let's just follow the lines here. It looks like it's going this way, and then it looks like it's going this way, and then, right? And then you can draw a few more ovals, right? Let's draw one at 2. And so on. Okay. Doesn't have to be perfect, but you get the idea. Now, the question is, what direction are we headed? So because our direction is going this direction, from this dot, we're going this direction with a slope of 1/2. And so now that I know my direction is this way, I can draw my little arrows. Okay. Kind of looks like planetary um, uh, traveling around the moon or something like, or around the sun. So, for those interested in astrophysics, this might have something to do with that. I don't know. Anyways, there you go. There's my circular focus. Okay, let's do the next one. Hit pause, rewind if you need to see that again. Okay, I'll walk you through one more, and then I'll just show the answers for one. So, once again, we've got our coefficients of -1, -3, 4, and 3. I want to find my eigenvalues. Okay, so to find the eigenvalues, I'm going to do -1 minus lambda, -3, 4, and 3 minus lambda. Let's find our determinant. So we've got okay, so to find the determinant, we've got -1 minus lambda and 3 minus lambda. Okay, so this guy times this guy minus -3 times 4. Okay, make that equal to 0. Okay, then we FOIL this out, and we've got -3 plus lambda minus 3 lambda plus lambda squared plus 12 equals 0. Okay, combine our like terms, and I get lambda squared minus 2 lambda plus 9 equals 0. Okay, so I automatically know that I can't factor this. There's no two numbers that multiply to give me 9 and add up to give me 2, or subtract to give me 2. So I'm going to have to use my quadratic formula again, like we did for the previous one. So x equals -b plus or minus square root b squared minus 4ac all over 2a. Okay, so a is 1, b is -2, c is 9. Okay, so x equals -2, so plus 2 plus or minus square root squared. Okay, that's 4 minus 4 times 1 times 9 all over 2 times 1. Okay, let's simplify this further. We get x equals 2 plus or minus 4 times 9 is 36. 36 -36, and 4 is -32. And then that's over 2. And then I have x equals 2 plus or minus, think of this as -4 times 4 times 2 all over 2. So that can be simplified as 2 plus or minus 4 square root 2 I over 2. And finally, we get 1 plus or minus 2 root 2I. So this is the part that we need. And we know that A is positive for my eigenvalues. These are my eigenvalues. These are my eigenvalues, and A is positive. So what color did I use? Red. Okay, so when A is positive, we have an unstable spiral. And when we have our unstable spiral, if we look at our sheet from Pablo, you can see that it's going to go outward, okay? Because the e to the at, if this is positive, this just keeps getting bigger and bigger and bigger, which is why it gets unstable and goes outward. Okay, so for my first trial of drawing this, okay, let's answer 2I, or II first. Okay, so II says find the slope. Okay, so I'm going to replace x with 1, so I've got -1 minus 0, and 4. Replace y with 0, so minus 0. So my direction vector is -1, 4. So in the x direction, I'm going to the left 1, and in the y direction, I'm going up 4. Okay, so my slope equals -1/4. But it's going up. Okay. All right, so just keep that in mind. And now we're going to draw our unstable spiral. So we could draw several of them, but I'm going to just start at 1.0. Okay, so let's just follow the lines. And you just do your best. Now let's go the other direction backwards. Okay. Now, because it's unstable, it's going outwards. So, and I know because from this point we just said the direction is -1 and up 4. So I'm going this direction. So from this dot, I'm going this direction, aren't I? So that helps me. This slope derivative, this one example, is enough to tell me what direction am I going. Okay, so now that I know what direction I'm going, I can draw my arrows. And okay. And it keeps spiraling out of control, getting bigger. Oh my gosh. Okay. For the rest of them, I'm just going to show you my work. Maybe walk it through a little bit. So, wrote down my coefficients, set up my determinant, calculated the determinant, used the quadratic formula, and then I ended up with here. And so my A is -0.2. So we know it's a stable spiral, it's going in. Okay. Oh, I didn't find the slope. Let's do that. Okay, so x dot y dot. Um, so I'm going to plug in 1 in for x, so negative 0.2 and plus 0 and negative 1 minus 0. So this simplifies to negative zero point 0.2 and negative 1. Okay, so my slope, rise over run, right? Um, let's just draw the picture here. In the x direction, I'm going negative just a little bit, and then down 1. So my slope is going to the left, 0.2, and down 1. So this is what we're doing. And so negative 1 divided by negative 0.2, we have a slope of positive 10 over 2. We have a slope of 5. Okay, but the direction is what's key. It's going down. So from this point at 1 comma 0, at 1 comma 0, my slope is going down. And you can see my arrows show that that's what's happening. And even if you didn't find this derivative, if you know that a is negative 0.2, then you know that it's going to be going inward. Okay, the next ones I'm just going to show you. Here's question 10. We know A is 1, so it's unstable spiral focus. We found our slope. And here's my picture. And it just needs to look sort of like this. If your picture is not exactly like mine, it's okay. I mean, maybe you drew less spirals. It's okay. Don't trip out if it doesn't look just like mine. Okay. And then here's the last one. Hit pause if you want to check your work. And here's my picture. It was very helpful having the phase portrait already drawn for you. I hope you appreciate that. And if you wanted to play around with this, as I said before, you can just type in the link that I gave you here, and you can type in any of your phase portrait diagrams. Okay, I hope that helps.